Hello and welcome to Lesson 7-2. Today we're going to look at solving systems by what we call substitution. So our objective is to solve systems by using the method of substitution, which is another method in addition to graphing. So in the previous video, we learned how to solve a system of equations by graphing. Today we're going to use what we call the substitution method, and like the name indicates, we are literally going to substitute something in. So the definition of substitution really just means to replace one variable with an equivalent expression containing the other variable. So in other words, we're going to substitute one expression into the other one. So in order to do this, we must have one equation that has been solved for one of the variables. Now in this case, it does not matter if you solve for x or solve for y. But remember, when we solve, it means we need to get x or y by itself. So it doesn't matter which one, it will work either way. You just have to have one variable by itself. So let's go ahead and take a look at a couple quick examples. So for example 1, it says to solve the system y equals 2x plus 2 and y equals negative 3x plus 4. Now this is the easiest form of substitution because if you notice, both equations have y isolated or y by itself. So in that sense, it really doesn't matter what we do. So what I'm going to do is I'm going to take this stuff here and I'm going to substitute it in for this y. So when I do that, I end up with 2x plus 2 equals a negative 3x plus 4. So again, I substituted this stuff that y was equal to in for the y into the other equation. Now what I have is I have an equation where I need to solve for x now. So to solve for x, I'm going to get all my x variables on one side. So I will add 3x to both sides. And I'm given 5x plus 2 equals, these are going to cancel. So that gives me 4. Now I need to get rid of my 2 by subtracting it from both sides. So I have 5x equals 2. And then now I need to solve for x. And I'm going to do that by dividing both sides by 5. So here I can see that x equals 2/5. So now this is part of my solution because if you remember, I'm looking for both an x and a y coordinate. So I just solved for my x coordinate. Now to solve for my y coordinate, what I'm going to do, because I have y by itself up here, I'm going to take this variable or this value and plug it in for this x. And again, it doesn't matter which equation I use in this case. So here I have y equals 2 times 2/5 plus 2. So 2 times 2/5 is really 4/5 plus 2. And when I add fractions, I need to get common denominators. So I have 4/5 plus, if I turn 2 into a fraction with a denominator of 5, that's really 10/5. And 4 plus 10 then is 14/5. Or I could say that that would be 2 and 4/5. Either one I would accept. So I'm just going to write it as an improper fraction, but my y value then is equal to 14/5. This right here is my completed final solution. Now if you wanted to, you could double check and take this 2/5 and plug it into either one of these equations, solve it out, and you should get a y value of 14/5 if you wanted to double check your work. Now for example 2, we're going to solve negative 2x plus y equals negative 1 and 4x plus 2y equals 12. So when I use the substitution method, typically what I do is I try to find an equation where one of the variables has a coefficient of just 1. So when I look at this equation here, I see that my top equation, we have this y variable that is by itself or has a coefficient of 1. So what I'm going to do then is I'm going to take that equation and I'm going to get y by itself. So to do that, I'm going to have to add 2x. So this gives me 2x minus 1. Now that I've done that, I'm going to take my 2x minus 1 and plug it into the y for that second equation. So ultimately, that gives me 4x plus 2 times, we said that y now is equal to this 2x minus 1, and then I'm still setting that equal to 12. So now what I have to do is I have to go through and actually solve for x. So I have 4x plus 4x, 2 times the negative 1 is minus 2, and this is going to equal 12. Well, now if I collect my like terms, this is going to give me 8x minus 2 equals 12. So I'm going to add 2 to both sides, and I have 8x equals 14. Divide both sides by 8, and I'm left with x equals 7/4. So again, in my coordinate point, my x value is going to be 7/4. Now I have to solve for my y. So because I've already isolated my y up in this equation, I'm just going to take this x value and plug it in up here. So really, I have y equals 2 times 7/4 minus 1, and now I just have to simplify. So 2 times 7/4, if I take a 2 out of here and a 2 will go into 4 2 times, this is really going to give me 7/2 minus 1. And if I get common denominators, I really have 7/2 minus 2 over 2, or I'm left with 5/2 for a y value. So I'm going to plug my 5/2 in up here. And this coordinate point right here is the solution to this system of equations. Now, just to tie this back into what we did in the graphing section, if you were to graph these two equations on the same graph, this right here would be your point of intersection. Please let me know if you have any questions. Otherwise, I hope you guys have a great day, and I'll see you in class.